Thank you so much for inviting me today. I'm honored to be able to speak with such an illustrious set of scholars. I'm also at the screen, back home on the screen. Okay, now the presentation is there. The title of my presentation is The Spectre of Carbon Leakage. So I think I just forgot to put up the title in my abstract, so I think we started out with that. And so the spectre of carbon leakage is really one of the core reasons why industry can name good reasons for why we shouldn't have very high carbon pricing, why we shouldn't follow in too much the strict regulation. So I said the spectre because a lot of it is not quite clear how much carbon leakage we've actually been seeing, but there's the spectre, there's the fear of carbon leakage, and that is holding back climate policy quite considerably. So I didn't just want to, this is not the title for a horror presentation, so I thought I'd also offer my solution, which is polycentric standard setting. And standard setting sounds boring, stifling, rigid. It doesn't sound very modern. So that is also why I need to have a boogeyman near the spectre to make standard setting appear as something fairly nice and maybe like a alternative than than that horror picture. So first I'm going to talk about the problem of carbon leakage because that is kind of a very technical term, so I think it's very important to introduce that. I will talk about the main approaches for countering carbon leakage so far, and I'm going to look at the main proposals that are currently being floated on how to address carbon leakage. Then I'm going to present some alternative instruments where we've seen some conceptualizations, but actually like some countries, regions, states have started to implement some of these alternative approaches, which are in the realm of standard setting. And then I'll briefly discuss the promise of alternative instruments and some of the research questions, because this is a research seminar here, so I thought it's probably good. Throw out some questions here, and so maybe we'll have some ideas on how to approach those questions.
Yes, I didn't get louder right now.
Okay. So let's look at the problem of carbon leakage. Climate policy instruments increase industry costs. For example, we have carbon pricing, that makes things more expensive for industry, and they may not be able to pass the cost along to their consumers, so they will lose out. Emission standards also make things more expensive. Renewable energy subsidies can also make things more expensive for industry, could raise product costs, so that could lead to carbon leakage, which is the relocation or competitiveness loss for domestic industry. So the kind of simple picture is that, oh, now you have very stringent climate regulation in a country, so the factories pack up and move somewhere else to a low regulation jurisdiction. That is probably a bit simple. What's more likely to happen is that over time you have competitiveness loss, so foreign competitors which are less regulated, they gain, so domestic industry will dwindle, there's a loss of employment, and so on. And the worst thing of all of that is that it doesn't actually lead to climate mitigation, because we would just end up moving production abroad, and we will feel like, oh, we're being very clean, but actually we consume products that are sort of carbon emissions that simply happen elsewhere. So this is a really nice narrative for industry to avoid regulation, to avoid stricter higher carbon prices, stricter regulation, and so on. And there is some truth to it as well. So it's a very good argument. So this argument really puts weight behind industry arguments against regulation, against higher carbon pricing. And what we've been seeing are a lot of exceptions made for industry. We've seen free allocation. This is the middle part here, free allocation of emission permits. A lot of them have been given out to industry, so that drastically reduces the effect of the carbon price. Then you also see a leniency on production-based emission standards, so basically a regulatory freeze, and also exemptions for industry from paying the full electricity price, which reduces energy incentives, energy efficiency incentives,
And it also places more burden on consumers and public finances, so consumers might not want to subsidize industry too much when they have to pay for clean electricity. So what are the predominantly discussed approaches to countering carbon leakage so far, which are compatible in principle with increasing climate policy ambition? First of all, we're talking about unilateral border carbon adjustments, for example, the European Union's CBAM proposal, and there are currently negotiations about that, and carbon clubs. So our border carbon adjustments basically aim to level the carbon price. So if you have imports from jurisdictions with a low or absent carbon price, then you basically say, okay, once they cross the border, you want to price them, and you want to make sure you have to pay the same carbon price for domestically produced or for imported products. And there are different ways of going about that, so I'm not going into the details here, but basically you level the carbon price at the border, or maybe behind the border, but you somehow level the carbon price. The problem with that is that it can only be implemented by the political unit that governs the tariff border, for example, the European Union or the United Kingdom. And you cannot do anything at the level of Berlin. You cannot even do something at the level of California, because you have a carbon price in California, but they don't govern the tariff border. So that is something which the federal government has to do in the United States. It relies on carbon pricing, this approach, and which is currently politically not feasible at the US federal level. So let's forget about that. And also relies on a homogeneous carbon price across the economy, which makes a lot of sense from a market liberal perspective. It is supposedly technology neutral, it's very cost efficient, you can get the low-hanging fruits first, and it supposedly avoids the pork barrel politics that means in excessive lobbying. And I recently talked to someone, an industry representative at the Royal Institute for Foreign Affairs, Chatham House, and that was very typically say he just doesn't like standards, because particularly in the United States, there's this idea just powerful corporations who lobby for standards that are in their interest. So from an orthodox, neoclassical political economy perspective as well, it's just standards are not very attractive because they open the doorways to a lot of this lobbying. But a homogeneous carbon price across the economy doesn't make so much sense from a political economy perspective, where you might say, okay, maybe let's better go for the sectors that put up a less resistance. Let's go for the sectors that maybe they are more ready to have higher standards, or that just cannot put up so much resistance. So let's pick them one by one. Let's go for the weakest sectors in that sense, or for the most cooperative sectors. And it also does not make much sense from a technology forcing perspective, because maybe you don't want to start just with a low-hanging fruit, but you also need to have pathways, mid to long-term pathways to actually force technology into a certain direction. For example, when we talk about green hydrogen steel and so on. And this is terribly complicated. So it's promising, but terribly complicated as well. And World Trade Organization issues and so on. So there's a whole there's a huge literature just discussing all the theoretical implications of this from a legal perspective. Now, seemingly more simple, carbon clubs. So this idea has been advocated by Nordhaus, Nobel Prize winner, and it has influenced the G7. I always need to figure out as G8, G7, but it has influenced the G7 and the German position in particular. The idea was to have carbon clubs, and then it wasn't quite clear what a carbon club would mean. In the beginning, we were thinking, okay, maybe if it's more aligned with the original Nordhaus proposal, that would mean a very sanctions-heavy club. You have this exclusive club, maybe just the EU and the US, with a certain ambition level, and then you would have tariffs. Then you would slap on tariffs on anyone else who doesn't share this high level of ambitions. So that could alienate non-members and even deepen the rift in the world trade system even more. So many people would be quite worried about implementing something like that. So right now we have this watering down and more cooperative versions, but the question is, can this actually, if it's so watered down, will it actually lead to a radical decarbonization of industry? And also carbon clubs, I mean, sounds really nice, but also runs the danger of a lock-in into the lowest common denominator ambition level. So let's say we have a carbon club, we've got a couple of members, we've got the EU and the United States. So maybe we will be locked into the ambition level of Poland, for example. So if we've got like some veto powers in the European Union, we've got vetoes across the carbon club. So we might adopt it, and then we are stuck at a certain level. So that also makes it more attractive to look at unilateral measures where you don't have to rely on this big coordination amongst the club. So what are alternative instruments that are available? So one is green public procurement that has been used to target embodied or life cycle emissions. And I'm going to explain the concept of embodied or life cycle emissions in a second. Then there are also mandatory embodied or life cycle carbon performance standards, either at the level of intermediate products such as steel and cement. And if you've been following this discussion, steel and cement are extremely carbon heavy building materials. And then also there are also standards at the level of final products such as buildings or vehicles. There are already some standards for buildings implemented, and for vehicles it's very important because obviously we have this discussion, what is going to happen when we have an electrification of the vehicle fleet. Should we not also take the embodied emissions into account here? Excise taxes is also an alternative instrument. I'm not going to go into that. Here it's basically a sin tax like for alcohol or tobacco or something which you could potentially levy at the state level in the US, for example. So what are embodied or life cycle emissions? Here on the left hand you can see all of the emissions. Let's say this is for a building. On the left-hand side, you can see all the emissions that occur before a building actually stands, before you can move into a building, before you can turn the key. So we've got the extraction of raw materials, transport to factory, manufacture of products, transport to the site, and the actual construction of the building. So then if we look at the building, or the finished building, it looks very nice, but we can also consider all of these steps which were necessary to produce the building, to construct the building. We can consider all of the greenhouse gas emissions that are associated with that, and then say, oh, those are the embodied emissions of that building. And in Germany, that has been called gray emissions. So you may know the difference between operational and gray emissions. You may have heard of that. And which brings us to the next category of emissions, which are operational emissions. So there's been a lot of discourse on how to, a lot of action and discourse on how to improve the energy efficiency of buildings, also in the name of tackling climate change, and that has been focused mainly on operational emissions. Now, if you look at embodied emissions and operational emissions together, and potentially also with the end of life, demolition of the building, reuse of waste materials, landfilling, and so on, then we look at the whole life cycle. So whole life cycle emissions. Here I just call them life cycle emissions because there's a lot of uncertainty at the end, and it's also quite questionable whether we should invest too much time in optimizing what's going to happen in 70 or 100 years at this point in time. But it's an important argument in the discussion. So let's look at green public procurement, slightly less spectacular because it's not a mandatory policy that would directly apply to industry, but it just uses the procurement power of government. And here, what has been really exciting is the so-called Buy Clean legislation in the United States. California has adopted it, Colorado has adopted it, and there has been a preparatory executive order at the federal level. And I'm going to talk about the details of the Buy Clean legislation in a minute. And there's also at the level of final, so that is at the level of intermediate products, so just steel or cement, concrete, and that when it comes to the federal level concrete, and we're going to go into those details. And there's also government procurement in Germany is also interested in life cycle assessment of buildings and so on. Let's look at mandatory embodied or whole life cycle carbon performance standards for final products. So the mandatory, now we're going to look at the mandatory standards or the public procurement standards, and for intermediate products, i.e. steel or cement, there has been discussion within the UK government to potentially adopt something like that, also aligned with the G7 considerations and initiatives on creating a market for green industrial goods, for green industrial products. And so there's a different framing for the same issue. You could frame it as green industrial products. And there are also EU-USA negotiations on common standards for the carbon intensity of steel. Looking at final products in buildings, so Finland, France, and Sweden have announced such standards, and they have been implemented in the Netherlands and in Denmark. Vehicles, the European Political Strategy Center has proposed such standards for vehicles as well. So what's really interesting about these policies is that you can not just implement them at relatively high levels, such as carbon pricing, but you can also implement them at lower levels, for example, at the city level, at the level of the lenders, at the level of states, and so on. So you can adopt them at very different levels in different regions. So that goes much more in line with a polycentric logic. It's much less centralized, and that has several advantages. But first of all, let's look at on what these standards depend. And they depend on information, because you need to have information on the carbon content of these products, on the carbon intensity with which they have been produced. So so that makes the role of certification really important. On the one hand, we've got product carbon footprints, carbon labeling, and environmental product declarations. And many scholars of climate change, climate governance have ignored environmental product declarations because they have a different name than product carbon footprints. But actually, these environmental product declarations comprise product carbon footprints. So what they do is they package the result of life cycle assessments into a verified document. And part of that are also the product carbon footprints. So what's really interesting is you've got this polycentric dynamic, this polycentric potential, let's say. So these policies can be adopted at different levels in different parts of the world. But when we take the informational dimension into account, this becomes really interesting, because this information is scarce, it's difficult to verify, there's no infrastructure, there's a lack of knowledge, and so on. But each new policy adoption can increase the incentives for the provision of information on embodied emissions. It can help to generate demand for expertise and also demand for data infrastructure. So each subsequent intervention, each subsequent policy adoption will be easier because there will be more infrastructure, more expertise, and more data. So some questions, which I'm also directing to you. What are the political economy implications of such standards? How can such standards be designed in ways that increase ambition rather than cause a backlash? And how can these standards interact with each other and also potentially with border carbon adjustments and carbon clubs? And what could be potential sequencing effects? So I've started to look at the coalitions behind these proposals, and I think what we can identify is a greater interest of relatively low carbon producers within high carbon product categories in standards for intermediate products such as cement or steel. For example, cement producers that manage to use CCS, green hydrogen steel. And here you may find self-interested businesses that try to implement standards to raise the costs for rivals or to put rivals out of business. And interestingly, carbon pricing was supposed to circumvent that mechanism, but it failed to be adopted, sufficiently widely adopted or effective. So this is something, it's kind of like a double-edged sword, this effect. And then there could also be a greater interest of alternative material producers in whole building standards, for example, timber or hemp producers.
Why would this be a problem? Because I mean, we've done this type of standards as a competitiveness raising instrument. We've done it in energy efficiency for products, for example, right? So we have standards that the Chinese cannot fulfill, so we keep them out of our markets. That's one of the drivers behind the rise of Japan as an electronics manufacturer and as a high-tech nation. It seems like a very good instrument to me. And if we do this, then okay, so some companies that produce the kinds of goods that we want benefits in order to push out others, but isn't that what we want anyway?
Yeah, I find this interesting because there's a mechanism for certain businesses to lobby for higher standards or to be okay with higher standards. So it's also a way of how you can break up this seemingly monolithic business opposition to stricter regulation. And I think it's something productive and which has its advantages, but some people might also criticize that. It will probably be bigger corporations that are better at fulfilling those standards, that are better at adopting green hydrogen, steel production, and so on. So
but is that what we actually see? I would expect exactly the opposite. That the big ones are the ones blocking, pushing for these, I would call them bollocks policies like CBAM in 2038 and all of these policies that have no impact. Whereas these things will have an immediate impact, and it's the small, nimble, the newcomers that tend to lobby for these things. So can we really see these fears that you voice, or are they fears that this could happen, or does it happen?
It's happened for the leaf market in the US very much so.
Okay, so there is empirical evidence that it's not a fear, it's a thing. Okay.
Okay, we should definitely continue our discussion on those details.
Yeah, sorry.
Thanks for the intervention.
Sorry.
So then the next question, how can such standards be designed in ways that increase ambition rather than cause backlash? And there's a real danger of putting off producers and consumers. For example, there could be potential limitations on product variety in the name of comparability or benchmarking. And yesterday I talked to an architect, and it seems like they might not like it too much if their liberty is too restricted when it comes to specifying what they would like to have in a building. It runs counter to this idea of technology neutrality. But I would argue that it's probably best to focus on the big chunks first. For example, steel, cement, glass. We don't need to regulate everything that is in a building or in a car. Right? There are also the danger that those products will be less appreciated. They could be perceived as ugly, as dysfunctional, as less comfortable. And I think this makes it really necessary to draw on participatory approaches here. And this is obviously very difficult because you have a lot of lobbying going on, but you also need to figure out what could be acceptable, how you can raise ambition, how you make those standards acceptable, how you bring architects on board, for example. And I think this could actually be a strength of the RIFs here because of your great experience with participatory approaches. And then also in the interaction between policy instruments is also a very interesting question. So for example, such standards could help to create more demand for data, which might then make it easier to implement something like border carbon adjustments. They could also be adopted instead of border carbon adjustments, for example, in the United States. Could be a complement to border carbon adjustments. Let's say border carbon adjustments have to be in accordance with this unitary carbon price across the economy, but then you could have standards to target specific sectors. For example, if you want to say, okay, we've got this common carbon price across the economy, but we want to force steel production towards using green hydrogen, so we have particular standards for that. And they could also be part of carbon clubs. It's also really interesting to look into how those standards could be combined, because you could imagine something like a combination of standards for intermediate products, let's say steel, rebar, final product standards like buildings, and you could also think of higher level standards, for example, in the form of planning permissions. Perhaps it would be advisable to do a life cycle assessment for wider infrastructure planning, not just comparing different designs of new builds, but also really consider whether it's necessary to build a new building. So one example, how Denmark tries to tackle embodied carbon in buildings. This year they started a requirement for the LCA life cycle calculation of whole life carbon for new construction. So it goes from construction to reuse over recovery and recycling. It applies to new construction of over 1,000 square meters, and they introduced a CO2 threshold limit corresponding to 12 kilograms of CO2 equivalent per square meter per year. This is for whole life carbon, so combined embodied CO2 emissions and operational CO2 emissions. So that is of course quite speculative, because you've got lots of different parameters in there, you've got user behavior, you don't really know the carbon content of the grid in 50 years time, so a lot of speculative parameters are in there, but there isn't really an escape from this complexity. And then over time they will reconvene and then decide on stricter standards over time. So there's been cross-parliamentary buy-in to this policy, so it's quite credible that they are going to continue on that path. So that is a really exciting development, and I think it makes a lot of sense to actually look into it and try to better understand what challenges they have encountered and what are their experiences currently with this process. Now, the Netherlands has also introduced a similar policy. It applies to all new homes and offices over 100 square meter. But what they do is a more holistic life cycle assessment for 11 impact categories, including embodied carbon. And interestingly, each impact category gets converted into a currency value with embodied carbon weighted at 50 euros per ton of CO2 equivalent. And there's a cap for the overall environmental life cycle impact at €1 per square meter per year. So that is quite abstract, and because you have more indicators there, you probably have a lot more room to play around with this and have an overall get more results, more of the results you want probably. So it's not as strict probably when it comes to embodied carbon, but it's there, and also a very interesting case study. So then let's go to the Buy Clean California Act. It's in effect since last year, and it stipulates maximum acceptable global warming potential limits placed on the embodied carbon of construction materials used in public works, and it applies to structural steel, concrete reinforcing steel, flat glass, and minimal wallboard insulation. And part of the history, was part of the narrative, is that they built a bridge in California and they procured Chinese steel, probably quite carbon-intensive steel, while in California they already had somewhat cleaner steel production. The US has a lot of low carbon steel production anyway, because they have a lot of steel recycling. They use a lot of nuclear power for steel recycling. So part of the criticism was that actually Californian businesses are disadvantaged because they have to pay a carbon price, and the state ends up buying cheaper carbon-intensive steel from China. So there's something like a protectionist element in there, and you could also think of it not just as Buy Clean California, but as a Buy California Act. And then drawing on that, there's been the US Federal Buy Clean Initiative, and the US says, the central government says it's the largest purchaser in the world, annual purchasing power of over 650 billion. And in 21, there was the initiation of a Buy Clean task force, and last year the General Services Administration issued ByClean standards for concrete and asphalt and federal roads. And all of those require environmental product declarations. And there's extra oomph for this ByClean initiative through the Inflation Reduction Act to the number of 4.5 billion. And recently the US also joined the International Industrial Decarbonization Initiative, and there are discussions on collaboration and alignment between the state ByClean efforts and the federal ByClean initiative. And this actually opens up very interesting windows for cooperation. I mean, on the one hand, you have a cooperation between, potential collaboration between the state level and the central government level in the United States. But these standards are also very interesting from a European perspective, because there could potentially be some mirroring of those standards in the procurement in Europe, and not just at the European level, but also at the national level, perhaps at the city level and so on. So different actors could say, hey, actually, there are those standards already, perhaps we can just match those standards or become more ambitious. So there could be potentially be a race for more stricter standards. And so there will be more demand for environmental product declarations, demand for more data in the United States. And in Europe, people could draw on that and reinforce that movement. And there are also these negotiations between the US and the EU on steel standards, probably mainly as a response to Chinese steel overcapacity, also something protectionist, so that's not going to be well liked at the international level. But we could see that as a potential mini carbon club in the making already, with some interesting potential synergy effects with those other standard setting processes. So yesterday I talked to this architect. I tried to convince my students in a way. Obviously I try to leave them to draw their own conclusions, but I thought it would be easy to make a case for them that those standards are really important. But I invited another student who's an architect, and when you talk to them, it sounds all incredibly difficult, because it's actually really difficult to know the embodied carbon contents in a building, particularly if you project it over 50 or 100 years. There's a lot of refurbishment, a lot of the different elements may not last very long, so it's very speculative, and so you have huge uncertainty ranges. And the more you look into it, the more complex it appears. So maybe hopefully I haven't given that impression to you, but this is why I'm thinking, okay, if it's so complicated, why bother? And there we go back to the status quo and this threat of carbon leakage, because carbon pricing, as it is now, it just doesn't work. I mean, even now we have become, we remember the slump in the carbon market, and now carbon prices are much higher, but still it's illusory when it comes to industrial decarbonization, because they get lots of their emission certificates for free. So pure reliance on carbon pricing is an extremely high risk strategy. Carbon clubs, there's lots of talk, but high uncertainty. But interestingly, embodied carbon standards could be part of those clubs. And then I think the biggest selling point for these ideas is really the power of polycentric initiatives. So you can have learning and experimentation at a variety of levels. You can circumvent these lowest common denominator positions, and the vanguard can go ahead at different levels. Let's look at some of the academic and applied policy learning I would like to pursue with my project. First of all, to learn from the different cases in terms of the political economy, in terms of policy design, what could be good sequencing, where does it make sense to put the initial priorities. Also instrument interactions are a really interesting question. And then also to continue to develop the theorization alongside this project, theories on polycentric climate governance, but also to challenge the economic orthodoxy, which has left us in this kind of straitjacket of only thinking of this supposedly technology neutral regulation via pricing. So yeah, I think those are the big points. Thank you very much for your attention. It's been an honor to talk to you, and I'm looking forward to your questions.